Hi hello friends, welcome to my channel. We are going to see about support vector machine. My name is Sujan and we are going to see the support vector machine. There we go. The content of going to learn is machine learning algorithm, classification using SVM and kernels in SVM and issues and SVM regression implementations. So what's machine learning? We already know. In general, a machine learning algorithm is used to predict the output for future further based upon the previous collection data. So with the help of previous collection data, we are going to predict or we are going to update the values. So support vector machine is a supervised machine learning algorithm applied for both regression and classification problems. So support vector is also called supervised learning. So these are the raw data. Here some we getting pre-processing the structure of data and machine learning will allocate to learning algorithm and then iterate to get the best model condition candidate models. So these are the things we come and learn in machine learning. So the SPM is plays a vital role. It's the most efficient and algorithm areas we use. Classification using SVM. So SVM we already seen is a basic support vector machine. So these are y-axis is x-axis. This is hyperline plane where this plane is divided as these data are the unit in for example these data are dogs and these data are cats. So this group of cats and group of cats not intersect with each other. So these are hyperplane which is also called SPM. So in this algorithm, classification will plot each data in a dimensional space where n is number of users you have with the values of each feature. A hyperplane is a line that separated data belonging to various class and properties. So classification of linear data. So these are linear data because the all data are similar to each other. But so these are called linear data. So we plotting the data. The linear data can easily classify by using hyperplane. So we can with the help of hyperplane we can classify the data with the unity. There are two hyperplane which divides the data. The efficiency of classification depends upon the best hyperplane chosen. So choosing the best hyperplane for the SVM, for example, the optimal hyperplane and the maximum margin. These are the maximum margin between this hyperplane and this hyperplane. So these are the data separated by separate hyperplane. So optimal hyperplane also used to for using the best hyperplane. So the hyperplane for the margin is maximum is the hyperplane optimal hyperplane. SVM tries to make a decision boundary in such way that the separation between the two classes is as wide as possible. Classification now move on to the classification of non-data data. In previous we seen only linear data, so we are going to see about mixing of all data. So for example, these data are interlinked and intermixed of both data. For example, the dogs and cats are mixed together in this data. So in this we are going to divide it with the help of this SVM. So classifying data in which linearly separable is easy by considering a hyperplane. But separating a non-linear data with a numerous dimension is not possible by drawing a straight line. So the solution is to map the data another space that can be separated linearly. So these are the non-linear data, separated data. So in this we have the add one more dimension that is called x-axis, z-axis. So we previously for linear data we used x-axis and y-axis, but here we dominating a three-dimensional data that is z-axis. From that we can separate the data. Now the data is clearly linearly separable. Let the purple line separating the data in higher dimension z is a k, where k is a constant since z is equal to x square plus y square is equal to k, which is equation of circle. So we can project this linear separation in high dimension back in original dimension using the transformation. So kernel system in SPA system. So you already know that in previous year, third year you study the kernel system. So kernels are used to become considering feature space which is highly dimensionally cost. So this x-axis, this z-axis. The z-axis used to for non-linear data, while x-axis and the y-axis used to for linear data. So input space is a space and give features to the space. So non-linear data can be classified by adding extra dimensions, but finding the correct transformation is not easy every time for the purpose we use kernel. So kernel were disadvantages in non-linear data. Different types of kernel functions. These are kernel functions. For example, k is it k xi xj is equal to summation of xi t per meter. Now, when we only need to compute k xj, we did not need to perform computation in I-dimensional space. Expressly, this is called kernel tricks. Some common kernel function used for the SVM is polynomial kernel, Gaussian kernel, and sigmoid kernel. So these are the kernels different. Linear kernel. The linear kernel is the simplest kernel form function. It is given by the inner product plus and optional constant c. So SVM with linear kernels. SVM with linear SVM with a linear kernel. So separation and linear with the RBF kernel. SVM with polynomial degrees 3. So these are 3 degrees where the kernel represent in this row. So these are types of kernel we use. So in the kernel, you also know that overfitting. Overfitting is nothing but both data are mixed together and get some error. So as well, the problem is machine learning method is overtraining. In the static, overfitting is a production of analyzing the corresponding to or closely exactly to particular set of data and may therefore fail to fit additional data or predict future further observation really. So the green line represents the overfit model and the black line represent regulated model, while the green line best to follow the training set. It is to depend on the data and it's likely to have a high error rate on new unchanged data compared to the black line. So black line, which means the regular data, so which is compared to green line, is a high error on it. Okay. So we already know linear separation but then low margin. These are margin, we are linearly separating the data structures. It's also called soft margin because that all these probably leaders correspond to solution soft margin. So SVM we used. So these are things we use. Okay, we come to the main application of SVM. So the main aim of SVM is to classify the linear data, unlinear data we already seen, and ISA data. So where are SVM are used in our day-to-day life, and we come upon many surroundings with the help of SVM data. They are using SVM data, which means support vector machine. So in fake detection, they're using text and hyper categorization using classification image. For classifying the image using this type of data, SVM and bioinformation in Aadhaar card and all, we are using bioinformation getting, and we are using SVM to classify the data. So protein folds and remote hormone direction, handwritten recognition, which also used in many competitive exam because we are checking the handwritten recognition for sign. They are checking whether verifying that they are using the correct people are signing the form or not. So with the help of the SVM model, we can predict also using this. Generally GPC, which means generalized predicting control. We also use in government sectors. So and environment science we are using this. So these are the application we are using SVM model. So finally, friends, we conclude the topic and going to we are coming at the end of our channel. So thank you, friends. I hope you understand all the topic I will come upon in this video. So thank you.